So from last time, I wrote down some stuff that I wanted to try doing. One of them is using bit flags or bit masks or whatever they're called for the base object stuff. So instead of just having booleans for different variables, instead having them as flags. Maybe there's an enum which holds basically constants for names for each bit, or you just specify each bit with a specific function, something like that. Just because I want to try it, see what it's like. Then I've also written some other stuff down that I wanted to do, like changing the target sources to private instead of public in the CMake lists, for declaring level in world, because I switched world to use a unique pointer instead of an automatically allocated level. So I might as well forward declare it in the header, and then private constructors for level in world, so that classes that aren't friends of them can't allocate them because the constructor isn't available and stuff like that. And then also this like asset thing, where basically I'm thinking you have like a JSON which specifies all of the assets to be used in the game, and essentially maps a name to the location, the location being relative to whatever this is. So for example, texture ones in here will be relative to this path, and this path is relative to the executable. So when you want to load a texture, you just say, I want to load this texture, right, player. So it gets this, it knows to look in the textures, it appends this to the end of this, and then loads that file path. I'm thinking something like that. And then you have like groups as well, where you can specify the player group requires the texture player and the sound jump. And so whenever you load the player group, it loads all of these. Or maybe because when you just have one texture, it might be a bit verbose to have the square brackets. So might add this as well, where you can just specify one, where it's a singular word instead of a plural word. Anyway, that's kind of the ideas. So I'm thinking, first of all, I want to do the CMake lists. I want to set the target sources to private quickly. That'll be in here, this. There you go, bang, that's done. Forward declare that in world. That'll be all fine. Yeah, because I think here, I think public means that the executable that's using your library, or like whoever's using your library, can see all of the public sources in their own solution. That's why, like in the last video when I was doing the test app, you could see the header object. I think it's because it was public, but I never changed it because I forgot about it. So I'm changing it now. I think that's it anyway. So let's build it. And yeah, and then do these two in Rider, just because Rider's really cool. Also, this input stuff, I'm not sure about this input stuff. I need to have another think about it, because I'm thinking, yeah, because obviously int, 0, for example, could reference, Q on the keyboard, right, for example. But then that wouldn't then reference the button A on a controller, right? The int would be different for them. So instead of having this device thing, I'm thinking instead I need to have something that turns some kind of thing that can say, I need some kind of key thing No, I do just need a vector, because you can say, you know, add the int of this, but I also need to specify add it just for the keyboard. Don't add it for the controller. Because if I want space to be jump, and that's, for example, an int of 5, 5 could be Y on a controller, right, or X, and I don't want that. So I add the int for the A button on a controller, but that could be N on a keyboard. So now 4 keys are getting triggered instead of 2. So I'm not sure still about the input manager. I'm gonna kind of just ignore it for now. It's kind of most things I do that I'm not sure about. So what was I going to do? I was going to have this be forward declared and get rid of the include and include it here instead. Right, that's done then. So yeah, and then private constructor for world and level, because world is the friend of level. I have a public constructor here. If I just move this to private, nothing would change, and this would still work, and I can delete the default constructor so that anything that wants to try and construct this is going to be unable to. So for example, if I want to construct it in the, yeah, so this is now unable to. No, it's not actually, it's not unable to. Maybe it's just incomplete. So I'm able to make unique. Yeah, so here we can say default constructor is deleted. And this is saying it's inaccessible. So we can't construct it basically. But we can still make unique. I assume this is going to fail to compile or run or something though. So that means we need a wrapper method in the world to be able to allow us to do that. It will be private so that only the engine can get it or can use it. And we want to say set default level or something. And we can just say current level, make unique. Bang. That's cool. So they set default level to do, default level to load. Yeah, so we need to load it from a file, but that'll come later. So the world also needs a private or a deleted default. No, a private default constructor, not deleted one. So now if the level wants to try and create it, we could say world. It's not going to be able to because it's non-public. Yeah, so we could just have non-public constructors and stuff for these. So I want to, what did I want to do? Yeah, that was it. The level does have an outer. I'm not actually setting the outer though. I'll set it to this and then set the outer of this. And then the outer of this is already set, so I don't need to do it again when moving it, I don't think. Yeah. So now the outer of this is always the world, so we can just make a method for get world. We can static cast actually. Although it's incomplete, so I don't want this to be in line. There we go. Use dynamic cast instead. I don't actually know, because dynamic cast it's got more of a runtime fee, right? Let's have a little look. Static cast, dynamic polymorphism. I used static cast, I read that to use dynamic cast, I don't get why. Code works. Can anyone show me an example? It's necessary to use dynamic cast. I don't know where you read what you read. As for that, there's plenty of information out there. Why your code works are two cases. An upcast, cast to the base class, is always valid with both static cast and dynamic cast, and also without any cast, as an upcast is an implicit conversion. Yeah. Could anybody show me an example with necessary dynamic cast operator? Dynamic cast is exclusively used for handling polymorphism. You can cast a pointer or reference to any polymorphic type to any other class type. A polymorphic type is at least one virtual method. Yeah, you can use it for more than just casting downwards. You can cast sideways or even up another chain. The dynamic cast will seek out the desired object and return it if possible. If it can't, it will return null pointer in the case of a pointer, or throw bad cast in the case of a reference. Dynamic cast has some limitations though. It doesn't work if there are multiple objects of the same type in the inheritance hierarchy, the so-called dreaded diamond. If you aren't using virtual inheritance, it can only go through public inheritance. It will always fail to travel through protected or private inheritance. This is rarely an issue, however. Some forms of inheritance are rare. When you cannot use dynamic cast, if you downcast and the argument type is not polymorphic. So they haven't said anything about why static cast is bad here, which isn't exactly what I wanted. Ordinary typecasting. Yeah, but why should you use dynamic cast versus static cast? Cast statically, as in at compile time. This is for classes that have a conversion between them defined, for example. So static works. It was a float, okay. However, dynamic casting performs it dynamically. This is most often used for polymorphism, as in changing between one instance of a class to another. For example, okay, static cast is also used in cases of inheritance when you know that you have an instance of derived of not of base. However, if you didn't, then you would be calling a function that doesn't exist for base. You get weird results. Dynamic will fail if no conversion. Okay, so static, if you know that the object is of a specific type, you can static cast it, but it doesn't. It's like undefined or something. If it's not, perfectly fine and generally preferable to use static cast up the inheritance chain. It is faster because it is done at compile time rather than runtime, and you can't have a class with an uncertain inheritance chain, so dynamic cast can't have failed anyway. So when you're upcasting static casts, you don't even need to do that because they're implicit, yeah. So it's generally okay to use static casts. I could use it here because I know for a fact that the level's outer is always going to be world, and world does inherit from object. That's like a fact. So I don't have to use dynamic cast, that would just be incurring a runtime cost. So I'm going to keep it as static cast, actually. But I don't know. Anyway, yeah, private constructor. Okay, let's do this. Let's do bit flag stuff. So basically, in objects, we currently just have this, but I want to have. I'm thinking an int, an unsigned int. Called like flags, which is going to say it's uninitialized. And we can have an enum. Call it eObjects flags or something. We can specify pending create, pending destroy, just as the two. This can be that, and then this can be that. So basically, we can then say, you know, mark for destroy, and have this use the flags. I don't actually know exactly what this is, but if we go eObject flags and then pending destroy, we can just like add it on essentially. I need to look this up. Let's look this up. C++, bit flags. So here they're specifying this, which is interesting. Is to do 1 to n operator, where n would be the current state count. This way you use the next bit every time, such the way the state value reference. The most common way to represent each possible state is in a simple enumeration. And then you have a uint8 flag value, obviously because it's 8-bit, yeah. So structs, collection states. Let's make an empty struct with an 8-bit integer, so we could represent 8 different states with this singular number. Of course, any size integer. Okay, yeah, let's use an 8-bit integer then. It's an unsigned character. I could just specify unsigned character then. I'll keep it as this, just for now. And we can specify equals 1 with something. I've got 0 and then 1 1. It's interesting, these things. Very interesting. So then setting a flag, we can do a pipe. So to set a flag to true, value we want to make the bit become 1, not matter what the previous value was. This is very easy to achieve with the pipe operator, since you're sure the flag is set on the input value, which is the actual flag. A bitwise or operation will always result in this bit set to 1, since it is 1 in the input. A quick visualization is our current value is 0, do OR operation with that. Right, okay, so this is OR, so we're saying if this one or this one is 1, set it to 1. And because of that, if there is a 1, it will be set to 1. And there is a 1 because we know that the enum that we're inputting is 1. So we can do a pipe here, or not. For some reason, my my keyboard language switching has failed me, so just do copy and paste it. So you can mark for destroy and pending destroy, unsetting a flag. This is obviously intended to do the opposite. So instead of mark for destroy, we can set created or something for removing the create flag. This will by default have the create flag. I don't know exactly how to set that up, but so when we unset a value, we get flag 3 as an input to unset. We flip all the bits of flag 3, and then we do an AND. Our current value had flag 2, 3 and 5 set already. Our current operation with the result. So we do an AND. Okay, interesting. So we can simply say, m flags do an AND equals, and then unset the pending create. Value. Then there's an exclusive OR, which is the caret. Interesting. So using a caret, which is actually an operator which was proposed for the reflection in C++ 26, which is quite cool. Checking if a flag is set. Okay. So we can use that as well. Say pending destroy. Or not. And we can just return. So this function is finding that if no one, you just kind of check it. So starting value is flag 2, 3 and 5 set. Perform AND with flag 3. So when we're checking if flag 3 is set, result is equal to flag 3. Okay. And then starting value has flag 2 and flag 5. Perform AND with flag 3. So we're just doing an AND. So saying m flags and pending destroy, if that's equal to pending destroy. So it's saying if the AND of these two is equal to so if the AND of these flags and flag 3 is equal to flag 3. We can also say pending create. We can return flags and pending create. So check if multiple flags are set. Interesting. Okay, well that's pretty cool. So basically when we want to, destroy something and have it actually be destroyed at the end of the frame, we just call mark for destroy. Yes, this would just be different flags for the objects. And that can be, lots of various things for that. Nice. So now, for example, in our level, we could... can we call pending create? It's probably... yeah, it's inaccessible. can say, you know, if pending create, do something, or, you know, mark for destroy. Nice. I want to call this set created. I want to call this something better, because I'm not sure set created is actually a very good name. Maybe unmark create. So you mark stuff and unmark stuff. Yeah, let's call it unmark create. But then you have, you know, mark for destroy and then mark create instead of mark for create. Maybe it should be mark for create and unmark for create. I don't know. Anyway, you know, you have the helper functions and stuff. So that's the flags done. And now it's just like asset loading things. So I'm thinking I don't know actually. No, I'm not going to do that now. I'll do it later. What I'm going to do now is create like a entity. Yeah, let's start making entities. That seems useful. Make a new entity.hpp. Got to comment this out. There we go. So I'm not sure about the entity. It's going to inherit from object and also from tickable and drawable and probably transformable as well. Gonna have public objects, public tickable, public drawable, and then public transformable. I'm pretty sure transformable is under graphics. I'm going to put these in a list. There we go. Cool. Add it to the CMake lists. Then the pub file again. Get out of here. Include the tails entity here, and then add it to the namespace. And then in the CMake lists here, add entity to it. Nice, okay. Rejig the thing. Redo the thing, the build thing, generate builds and stuff. Now we have this wonderful entity. Which we'll need to do stuff, but maybe no. Let's do entity stuff. So, what do we need an entity to do? We need it to be able to spawn. So we need methods for, like, you know, on spawn and stuff. I don't know if this is going to be protected, actually. I don't know if I should call it like spawned or just spawn or on spawn. I don't know exactly which kind of terminology I should use. I'm just gonna have it for spawn, on spawn for now. Just gonna have it so we can tick. And also draw. I also don't know if I want an entity to be, just every entity to be a sprite. I'm thinking I might. I don't really want to have the complexities of having entities have components. I just want to be able to say, okay, make an entity and have it have this image and, you know, this kind of thing. So in that case, we don't want to inherit from these two, we want to inherit from sprite. But I want to try and make my own kind of sprite class as well, with what I think is the vertex array. Basically making my own sprite with the vertex array. Because there is a tutorial on here. Designing your own entities with vertex arrays. And you can do some cool stuff like gradients and things. Yeah, there's some really cool kind of stuff you can do. Yeah, so I think I want to try and do something like this. But until then, I just won't, I think. Because obviously children can have like whatever members they want, right? Like they can just have a variable for a sprite to have a second sprite. They can have a variable for text if they want to have text on the entity, right? They don't specifically need a vector of components. And if you just want an entity to exist in the world as like an info entity or something, like Unreal has an info actor, you could just not supply it with a texture. Yeah, right, I'll do that. So entities will be drawable and stuff. Yeah, so yeah, we're gonna have a virtual void for despawn as well. We can make the level a friend. And then in our level we can actually spawn an entity, which I'll make a function for. We'll have two spawn entity functions, maybe more, where we want to have a unique pointer come in. Going to include a vector here as well. Have a unique pointer to entity, which I need to forward declare. This will be the entity to spawn, and so what happens is we just actually we should probably return a entity pointer. this will just return static cast to T from spawn entity, and then we can do like a make unique or something. Yeah, I feel like I'm not actually going to do that because I want to have the... Actually, yeah, that's what I want the entity to have. I want like a pre-spawn, post-spawn and stuff like that. Post-spawn, despawn, post-despawn. No, the despawn thing's going to be... Post-despawn can just be the destructor. Despawn, let's comment these just to make sense of them. Called as soon as... or called the same frame as this entity is spawned. This is called the start of the next frame after this entity is spawned. Called the same frame this entity is despawned / marks for destroy. And basically, yes, so to have something called the next frame will be the destructor. So we can then do a static assert here for is base of, which I actually realized is actually a structure. It's just a templated structure, I think. Or not, never mind, it's a variable. I don't know. What? It's a variable that calls this, which is a predefined thing. Interesting. Anyway, the base is entity, and that's T, and then we can specify failed to spawn entity. It does not derive C entity. And then after that, we can actually spawn it. We can say auto results equals make unique. Say result actually we no we can just say this, yeah, result spawn, yeah, called the same frame. This will be the spawning one. Need to specify the outer to be this, and of course we're running off T here, so yeah, these should be fine anyway because we're static asserting it to make sure it's a child of entity. And then I think that should be fine for now. This spawn entity will actually be private. This is meant to be only used for the level's sake, not for, actually spawning entities from elsewhere. So we don't need to do any checking in here because we're only ever going to use it in here where we know that it needs stuff. So we can probably call it something like this, right? Spawn entity implementation. Although that's kind of lying, because if it's the implementation, we should set the outer and stuff. So, okay, sure, let's do that. No, entity, here we go. We want to do that, and then we can return entity.get, but I need to actually have a vector of entities. It'll be a unique pointer of entities because the level owns the entities unless you move them out. So here we can then say entities dot in place back, move the entity into it, and then here we can specify instead of entity, entities dot back dot get, and then that's that. And then we can have pre-tick, which will simply loop through the entities. I do actually, before I forget, I want to have this be, how do I set a flag by default? Can I just say pending create? Is that something I can do? Because I think C++ has a bit field or something, right? I'm pretty sure I saw it somewhere. Oh, bit set, here we go. Then what would this be? Unsigned char. That's a size T. Okay, so you're going to specify. Well, hang on. Let's look at CPP reference for this one. Whoops. You just say 2, right? I assume, or something. Or is this going to be 2 size T's? Or just 2 bits? Class template bit set represents a fixed size sequence of n bits. Okay, so yeah, it is. Let's say 2 bits. Bit sets can be manipulated by standard logic operators and converted to and from strings and integers. For the purpose of the string representation and of naming directions for shift operations, the sequence is thought of as having its lowest indexed elements at the right, as in the binary representation of integers. All member functions of bitset are constant expression. It is possible to create and use std bitset objects in the evaluation of a constant expression. Okay, cool. We can set, reset, flip. That's basically what I'm looking for, is just human readable names for like the crazy operations that we're doing here, essentially. So if I say, you know, bits.set, we're setting at the position pending creates to true, yeah. I assume that's basically what we want. I'm going to leave it like this for now. Can come back to it. Anyway, the entity, no, the level, the pre-tick, we can loop through the entities via reference and basically pre-tick them. And then if the entity is pending create, then we can say entity mark for create, or on mark for create actually, and then say entity spawn post spawn. There we go. So post-spawn is done here in pre-tick if they're pending create, which we then set them to not pending create, and then that's all good. And then we can say post-tick. It's very similar. What the? Why is it doing it inline? What? Ryder, why are you taking so long? Why are you doing an inline definition? Hey, what? Why are you doing an inline definition? I'll just do it myself. There we go. Post tick. Right, we can do it for each or whatever. Just to keep it consistent, let's do that. Entities. Entity. Put the thing there. Right. So now here we can say entity post tick, and then actually no, we don't. This is where we want to actually destroy stuff, because this is where we're gonna actually erase stuff from the vector in this loop. Despawn is just, if we say, destroy entity, just have a normal pointer into entity. We can say entity mark for destroy, and then entity despawn. Basically that's that, and then we don't even need to have this as a method. We could have it in the level, in the entity itself actually. We could do that actually. We could have a public method, call it destroy. Say mark for destroy on this, called despawn. And then in the level we can just say destroy and essentially just wrap it. We could make it static, I don't want to. And then in the post tick, we don't want this to be a range based one. We want it to be an iterator one, but we want it to be a reverse iterator. So we're going to say it equals m underscore entities dot r begin, I think. And then if it is not equal to entities dot r end, then we can say it get post tick, and then if it gets if it's pending destroy, then we can simply erase it. Can't erase a reverse iterator. I need to look that up, can't remember how you do that. And then else we can increment it. Iterate and erase reverse iterator vector. Okay, so we have a thing here where they're doing reverse iterator I in I'll begin. Look to that, then you increment it, and then if it's that, then you erase it. Apparently according to the standard relationship I.base. Oh yeah, you can do a thing. Yeah, you can just say .base in a reverse iterator. I forgot about that. There you go. Just do that. Reverse iterator I is unchanged. Yeah, you need to specify iterator again. Could I just say it equals that? No, because this is a reverse iterator, and erase returns a normal iterator. So basically, someone here is suggesting do a declare type here on this, which seems utterly barbaric. It seems very weird. And to also do std next it dot base, the next one. Now, I don't know if this actually works. I don't really care at the moment. I'm just going to leave it as it is and test it later. Sick. So we have our post-tick kind of cleanup stuff happening in the level. Obviously we need to actually tick all of the entities as well. That can just be done with a for each loop. Or a range-based for loop. We can say entity, no, if entity, if it's pending create, if it's not pending create, then we can tick it. If it is pending create, we don't want to tick it. And we still want to tick and stuff if they're pending delete, or pending destroy even. And we can just do the same thing here, except instead of this, we can say target.draw entity and states. Nice. I don't want the quotation marks, I prefer these things, the angle brackets. Right. Cool. Now our entities will be successful in their missions in existing. So the entities need a way to get the level, so we can forward declare. We have forward declared level, get level const, and we also want to make this a no discard, and we can return static cast to level from the outer. Need to include level. There we go. So there you go. You could also actually in objects have a method called like get typed outer, which will be templated. Where it will return a pointer get typed outer, and it literally just traverses every outer until it finds one. So we have objects outer can be equal to the outer if outer, no, if a dynamic cast, hang on, I'm going to look at the source code of my old Tails engine just because I want to see how I did it there. Right, so in here we have this, we have a thing where we go, we have a while loop. Here I want to have a for loop where we say, you know, objects, let's call it p outer. No, let's just call it p underscore outer, which will be the outer. And then we want to see if it's valid. And then at the end of each iteration, we want to say p outer is going to be equal to p outer outer. And then we can say if types outer is equal to dynamic cast to t from p outer, then we can return types outer. Else return null pointer. Yeah, so if our outer, so we create our outer, only run the for loop if it's valid, and then at the end of each iteration, get the next outer, check if it's valid, and then yeah, so that will make sense basically. That's all good. Cool. So now we could just say, you know, return get typed outer sea level. But the issue with this is, what's it all about? Oh, it's because it's not const. We can make it constant. The issue with this is we don't need to. We can just static cast because we know that the outer of level is going to be that the outer of entity is going to be level, that the outer of level is going to be world. If we have something where we don't know what the outer is, or we know that something like the engine isn't the direct outer, but we don't know how many outers to go up, then we can do that. So if we want to have a get engine method in the entity, which we probably do, then we can either get world from get level, get engine from get world, which we don't actually have. No, I want the engine. We could just do that, or we could say get typed outer. I don't know. I think for widgets it'll be a lot better, the typed outer thing, because then you can straight up, you know, get a specific parent. But I don't know. Anyway, we want to return a static cast, not a struct called stat. Why would I? What? Static cast to engine from outer. And of course, we need to include engine. So now in our level, we could get engine by just wrapping the get worlds one, but I don't really want to do that. Or do I? Because then I don't need to include the world in the entity. Sure, why not? It's not really going to do anything bad, so. Get engine. Return get world dot get engine. Sure, that should be a reference, not a pointer. And now in the entity, we can have a get engine as well. And say return get level, because we already include level, get world, or get engine even. Bang. So I don't need to include world in here, which helps a tiny bit. Nice. So our engine sets a default level, which is good. We then tick the world, pre-tick the world, tick the world, draw the world, post-tick the world. The world then, you know, does this stuff. You can open stuff and things. The outer's set properly and stuff like that. We then pre-tick the level, tick the level, draw the level, post-tick the level. The level then pre-ticks the entities, ticks the entities, draws the entities, post-ticks the entities, sets the outers and stuff, and things like that. So that should all happen quite nicely. And that's pretty much all I wanted to do, I think. Actually, no, this was assets that I wanted to do here. Do I do assets? I could do assets. I'm thinking we have context-specific assets, but the assets are essentially shared pointers. Yeah, but I'm thinking they're stored as weak pointers. So when something wants to use an asset, it says, hey, I want to use this asset. And then it queries if that asset exists. If it does, it looks at the weak pointer. If the weak pointer is valid or whatever, it says, here's your shared pointer. And it gives the thing that wants the asset a shared pointer. But if the weak pointer is not valid, one, it should have been deleted, but also two, it doesn't return a shared pointer, it returns null or something. I'm not sure. But that'll be it for now, at least. So have fun.